Hi guys, welcome to Algebra 2. This video is for probability unit that has your homework thing. So let's go ahead and answer your questions. For the first question, a student is buying a school hoodie. They can choose from 4 colors. So basically probability is mix of different events. So here your first event is the fact that you could choose from 4 colors, and your second event is you can choose from 3 sizes, right? And we learned from a fundamental counting principle that when you have such things, you can multiply those numbers to get how many combinations you can make, right? So for the first event, there are 4 possible combinations to make. 4 possible options to pick from, and for the second one there's 3. Together you can make 4 times 3, which is 12 different combinations from there. Question 2, a bike lock uses a 3-digit code. Each digits can be any number from 0 to 9. Again, your event here is it's the fact that it's 3-digit code, so there are 3 different possibilities. For the first one, you could choose from any number from 0 to 9, right? Any number from 0 to 9, that's 10 different numbers. Now I'm going to assume that you could repeat the numbers here. It doesn't specify that you can, and if I were to think of like my passcode and stuff, you could definitely repeat your numbers, right? Your 10 times 10 times 10, which is 1,000. So 1,000 different codes you can make, right? If the first digit cannot be 0, so now I'm limiting myself that the first number cannot be 0. So then how many options do I have for the first one? Only 9. But the rest could be still, right, 10. So there are 900 different codes I can make. For this one, Mr. Patel has his birthday as his password. I'm going to use my birthday, which is 27th August. So 2708 are my possible. I use date first and then month. Outside of America, that's why. But 2708 are my numbers. So let's just say this. What are the different codes I could use? Like I could create. There are 4 different options here, right? 4 options, and I'm gonna have to create a 4-digit code. And since I can repeat them, it could be any of these 4. I could pick any of these 4 numbers, right? For any of the spots. So it's basically 4 to the power of 4, which is 256. But for this one, I cannot repeat, right? So even though for the first one I could choose any 2, 7, 0, or 8, but for the second one I will only have 3 remaining, and then 2, and then 1. So when this happens, this is called a factorial. 4 factorial, when every single integer, a positive integer, less than the number itself, are being multiplied to it. That's in factorial. So for example, 5 factorial will be 5 times 4 times 3 times 2 times 1, right? This is something it's very important that you learn this right now, especially for pre-calc as well. But yeah, 4 factorial is 4 times 3 times 2 times 1. See, what are the numbers less than 4? So 4, 3, 2, and 1. And you multiply all of them to get 4 factorial, which is going to be 24. Alrighty, moving on to the next question. Hopefully this is still recording. If it's not, let me just make sure it is. If it's not, then I don't want to. Okay, continue. It's recording. Okay. You spin a prize wheel that is divided into 4 equal sections: red, blue, green, and yellow. You spin the wheel twice. Now, are these even independent or dependent? Well, if I spin the wheel first time, that does not decide what I get on the second time, or that doesn't affect the second event, right? So it's independent of each other. What is the probability of landing on red on the first spin and green on the second spin? Well, 2 spin. Okay, 2 different events right now. I want red on the first one and green on the second one. So I ask myself, how many possible different combinations are there? 4, right? Red, blue, green, or yellow. Out of which, how many are red? Only 1, so a 4th. Same thing here. There's only 1 green out of 4, so it's 1 over 16th. A student has a study mix with 10 songs. 3 are jazz, 5 are lofi, and 2 are classical. The player is on the shuffle and does not repeat. It does not repeat the songs, right? So basically now what I'm going to play first doesn't decide, but changes the probability of what I play second, because it's going to lower the number of songs possible, right? So like for example, if there's like 3 songs that I play, I don't know, like jazz, classical, and lofi, let's just say that, okay? If I play the jazz first, now the probability that the second one is classical lo-fi is 50%, right? Compared to first, it would have been 33%. So it changes because you're repeating the songs. I mean, you're not repeating the songs. So these events are dependent. What is the probability that the first played song is classical? Well, I ask myself, how many classical are there? Well, there is 2 classical songs out of 10 times another classical. Once I play the first song, there's only 1 classical song left out of 9. So which is 2 over 90. Okay. Oh, you cannot see. Okay. You could not see. Okay, once again, I don't know if you could see or not. Okay. For all of this. I can't remember. Oh, I should have seen this. Oh my god, I'm so sorry. Check this out still. 1/4 times 1/4 equals 116. 2 times 1/9 equals 2 over 90. Okay. You're holding a small stack of 5 cards and ace. So there's 5 cards in your hands. And you draw 1 card and you keep it. Right? So that means it's going to lower, it's dependent event, right? So how many total ways can you choose 2 cards? Again, 2 events. For the first one, there are 5 cards to choose from. But for the second one, there's only 4. So there are 20 total cards to choose from. What is the probability that you draw the ace first? Well, how many aces are there? 1 out of 5. How many kings are there? 1 out of 4. Because once I take out my ace, I will only have 4 left. So it's 1 over 20. Alright, a bag contains 3 marbles, red marbles, 5 blue marbles, and 2 yellow marbles. Okay, you guess. What is the probability that you draw a red marble? Well, there's 3 red marbles out of 10 times, then a blue marble, that's 5. Again, it says no replacement, right? So I'm not going to place it back, so I will have 1 less marble. Then, finally, another red marble, which I will have 2. Here was 3, but in this scenario, I would have taken 1 out, so by the time I get here, I will only have 2 left. So 3 times 5 is 15, 15 times 2 is 30, over 720. I'm hoping that's right. You guys can do the math. Alrighty, solve for z. Now, w plus z over y equals x minus 2, right? So here, first, you do realize this. An equation has 2 sides, left side and right side, right? Z is on the left side. What else is with it? There is w and there is y. And I have to do inverse operations to figure out, to isolate z. First I will get rid of w because it's being added, so I'm going to subtract w on both the sides. So then my new equation is z over y equals x minus 2 minus w. And then I will have to do times y, the entire thing. So z equals y times x minus 2 minus w. And that is my answer. You can also distribute the y, right? Recursive definition consists of 3 things, right? Your first term, which is 7, then the definition of the next term. So next term is basically adding 5, and then you should say n is greater than 1. N integers, but you don't have to say integers anymore. Explicit definition, this will be given to you. This definition, fn minus 1 times d. First term is 7, the difference is 5. Distribute the 5, you get 7 plus 5n minus 5, which is 5n plus 2, and that is your answer. You can also check it by plugging in. Factor by grouping. Grouping basically means grouping them, right? So I'm going to group the first 2 terms and the last 2 terms, and I'm going to ask myself, what do the first 2 terms have in common? Well, there is x squared that's common, and then I'm left with x minus 2, and then here that's negative 4, and left with x minus 2 as well. Then I say x minus 2, I say x minus 2. They both are same. If they are not, you cannot move to the next step. But because they are same, I can combine them and then combine the next few terms, which is x minus 2 and then x squared minus 4. Now, x squared minus 4 is difference of squares. So I get x minus 2 and then x plus 2 and x minus 2. This x minus 2, this x minus 2 becomes x minus 2 squared and then x plus 2. Now, you could also leave it here or you can leave this here. It doesn't matter. Okay, part B. First 2 terms, x squared, x minus 3, plus 1, x minus 3, x squared plus 1, x minus 3. A lot of students will separate this into x plus 1, x minus 1, which will be wrong, because this is not difference of squares, this is sum of squares, which you cannot do. So this will be your answer, final answer. Moving on to the next one. Exponential. Express the population in functions of time, w in weeks after the purchase. I see 2 points here. It's an exponential curve, and so whenever I think of exponential, I know this one thing. It's always going to be the first term times the ratio to the power of n over whatever, like however long it takes for the ratio to happen, and I can explain that in future. Give me just a moment. The first term is 2. The ratio is from 2 to 18. So what do I multiply to 2 to get 18? It's 9. But the question is, it doesn't take 1 week to get to 18. It takes 2 weeks, right? From 0 to 2. So I have to divide by 2. Basically, when I plug in 2 now, and 2 divided by 2 becomes 1, that's what it's saying, that it will happen one time. But if you don't leave it at that, and you plug in 2, then you're squaring by 81. You don't want that. So basically, it's however long it takes is your denominator in the exponent, right? Write an expression to represent population in days, right? Then you need to ask yourself, how many days are in weeks? Well, 7. So then it's 2 over 9. Days over 7 times 2 is 14, because it's days over 7, right? So you get 2 over 9. Since you're plugging 12 for D, you plug in that, and that is your answer. Alrighty, moving on. A survey was given to, you guys can read that. I'm not going to read them. I'm too tired to read it. But I said the keyword here is OR. When I say OR, I'm going to separate each events and I'm going to add them. Okay, I'm going to separate each events and I'm going to add them, but I'm also going to subtract where they both happen twice. Here's what I mean by that. What is the probability that a randomly selected student plays a school sport? First event, plays a school sport. How many students play? I'm going to circle that. School sport, right? So that's 40. 40 out of 100. And is a member of school club. School club is this. So 15 plus 40, which is 55 out of 100. But as you can see, this 15 is circled twice. You can't do that, right? So you're going to have to get rid of it one time by subtracting it 15 over 100. So then your answer is 80 over 100. Okay, what is the probability that a student who plays a school sport? I would circle that, which I already circled already, which is 40 over 100, right? Oh, never mind, sorry, I made that mistake. This is not all proper probability, so I cannot separate them. One second. What is the probability that a student who plays a school sport, so I'm only focusing on what I've circled here, is also a member of school club? So out of this 40 people, out of this 40 who play school sport, how many are also school club members? 15. So it's 15 over 40. It's a conditional probability. Here again, conditional probability, right? This is the condition because it's on the right side of the given side, right? Not playing sport. So I'm going to circle that. How many people do not play sport? And it's this many people. 60. So out of the 60 people, how many are member of school club? 40. So 40 over 60 is your answer. Alrighty, the next one. What is the probability that a randomly selected teenager has a YouTube channel? Again, YouTube channel, and I see the word OR, so I'm going to have to add it, right? So I'm going to look at YouTube channel, which is here, and that is 42 over 100. OR has a premium music subscription, right? Premium music subscription is this, which is 30 plus 30 over 100. But then this 12 is done twice, right? So I'm going to get rid of it one time. Minus 12 over 100, which is 60 over 100. That's your answer. What is the probability that a teenager who does not have a premium music subscription? So I'm looking at one that does not have a premium subscription, and there are 70 of them. Out of the 70, how many have YouTube channels? 30. So 30 out of 70 is your answer. Find the value of probability that no premium music subscription given no YouTube channel. So how many people have no YouTube channel? So that's 18 plus 40, which is 58. Out of this 58, how many have no subscription in music? 40. So 40 over 58 is your answer. Now, use the probability table to find each for, okay, what is the probability that they are male? That's 40 plus 16 plus 35 out of however many they are. And let me get a calculator. Where did my calculator go? Right here. So I will basically add however many males there are, divide by however many people there are, right? So 40 plus 16 plus 35. So there are 91 males. I'm just gonna write down here as well 91. Out of how many? 91 plus 15 plus 24, 150. So the probability that you pick a male, it's 91 over 150. What is the probability that they are male or majors in chemistry? Again, they're using the word or here, so you're gonna have to subtract it. But probability that you pick a male is 91 over 150 plus chemistry is 55 over 150. But then you also have to subtract where they both intersect, which is 35 over 150. So 91 plus 55 minus 35 is 111 over 150. Alright, what is the probability that you pick a student that majors in physics given they are male? And I know there is 91 males, right? Out of those 91 males, how many major in physics? 16. So 16 over 91 is your answer. Alrighty. Now, this is going to be interesting. There are 20 basketballs and 30 soccer balls in a bag. 12 of the basketballs are brand new. So I'm just going to write them 12 new basketballs, 18 new soccer balls. That means that there are 8 old basketballs and 12 are used, not old but used. You get what I'm saying? Soccer balls, right? Are used. What is the probability that a randomly selected ball is a basketball given that it's a used ball? Oh, you cannot see. Okay. Again, all I did was I read this, 12 of the basketballs are brand new and 18 were soccer balls, new balls. So that means I subtracted from however many there were 20 total. That means the 8 must have been used basketballs and 12 must have been old. Now, given that it's a used ball, there are 20 used balls. Out of those 20, how many are basketballs? 8. So 8 over 20 is your answer for this one. Moving on. I'm gonna draw the Venn diagram. There are two events, right? Popcorn and a drink, right? So popcorn is on the left side and drink on the right side. 72% customers buys popcorn, 6% buys drink, 18% does neither. So does both. Oh my god, what is wrong with me? Does both. Okay, what is the probability that customer who buys popcorn, so I'm looking at how many people are buying popcorn, which is about 90, right? Out of those 90, how many buys drink? 18. So it's 18 over 90. What is the probability that customer who buys a drink, so I'm looking at this, there are 24 people who buy drink, people. Out of those, how many buy popcorn? Only 18. 18 over 24. And that's your answer. Perfect. That's it. That's the end of the video.